Picture a customer typing a very specific error code into your search box, right alongside a plain English description of what actually went wrong. A keyword search would nail that exact code, but completely miss the meaning. A semantic search would grasp the meaning perfectly but blur the precise code into something fuzzy. Each approach is strong exactly where the other is weak. So what if you simply ran both and combined them? That is hybrid search, and it has quietly become the default recommendation for serious retrieval systems. Let's see why it wins. First, let us look at the gap a single retriever always leaves behind. Any single retriever forces a compromise. A dense embedding model understands meaning, so it handles synonyms and paraphrase beautifully, but it blurs and misses exact terms like product codes, names, and rare jargon. A sparse keyword model is the mirror image. It nails those exact terms, yet stays completely blind to meaning. Whichever one you pick, you are quietly losing an entire category of queries. Hybrid search refuses that compromise by running both retrievers together and merging their results. The exact match query still finds its code through the keyword side, and the conceptual query still finds its meaning through the embedding side. Real queries genuinely need both. A search for a specific fault code that also asks about resetting a device wants the literal string and the underlying concept at once, and hybrid gives you both. So how does hybrid search actually work under the hood? Follow the two lanes and watch where they meet. The first lane runs sparse keyword retrieval, typically BM25. It looks for the literal tokens in the query, so exact codes, error strings, and specific names all match reliably. This is the lane that guarantees a precise term the user typed actually surfaces the document that contains it. The second lane runs dense embedding retrieval. It encodes the query into a vector and finds the documents whose meaning sits closest, catching synonyms and paraphrase that share no words with the query at all. This is the lane that understands what the user actually meant, not just what they literally typed. Now comes the hard part. The two lanes produce scores on completely incompatible scales, so you cannot simply add them together. The standard fix is reciprocal rank fusion, which ignores the raw scores entirely and combines by rank instead. A document ranked highly by either lane floats to the top, and the whole thing needs no tuning. The result is one merged, fused list drawn from both worlds. Exact match queries keep their precise hits, semantic queries keep their conceptual ones, and the fusion makes the whole system robust across the messy mix of questions real users actually send. Strip it all back, and three ideas define hybrid search. It runs both retrievers at once. Sparse keyword matching and dense semantic matching work side by side, so every query is answered by the literal words and the underlying meaning together, instead of forcing you to pick one philosophy up front and hope it fits. It fuses the two ranked lists. Because the scores live on different scales, hybrid search usually combines them by rank, most often with reciprocal rank fusion, so a document favored by either retriever rises to the top without any delicate score tuning. It is markedly more robust. Across the diverse queries real users send, hybrid search stops losing exact match questions to the embedding model and semantic questions to keywords, which is why it is now the default for production RAG and enterprise search, usually followed by a re-ranker. All right, let's lock in what matters. Hybrid search combines sparse keyword retrieval with dense semantic retrieval, giving you the strengths of both and consistently beating either method used alone. It exists because their weaknesses are complementary. Dense retrieval blurs exact terms. Sparse retrieval is blind to meaning, and real queries genuinely need both at the same time. The core challenge is fusion. since the two produce scores on incompatible scales. Reciprocal rank fusion solves it by combining on rank instead, robustly and with no tuning. Most vector databases now support it natively, and it is the default first choice for production retrieval, often paired with a re-ranker. If you like retrieval explained without the hand-waving, we unpack a great deal more of it over at standardy.com. Come dig in with us.